Okay, let's go to the whiteboard again. And so we're going to do now another one, right? And still the same question. We want to solve this model. We want to do spam detection, okay? This one actually has some easy things and some hard things, right? So we're going to do spam detection. Okay. So, right. So spam detection here, again, we start with the model. It's got inputs, it's got outputs, right? So what are the outputs here? What should the model do? Detect spam, not spam, right? All right. So that's going to be then classification. Yes. And you can say the classes could be -1, +1, or they can be 0 and 1, something like that. Okay. So we'll play with that. So that's good. Spam detection. Okay, so this is N, this is N, M. What is this value here? Do we know it already? What is it? How many columns do we have in Y? Just one, right? Yeah. So it's 0, 1, 1, 0, 0, 1, and so on. We've got that defined. Yes. So now, what is a sample? So in this case, we need to think about that. So what is a sample? Spam comes in what form? Emails, correct? Am I saying that correct? All right. So that means a sample is what? An email. You get an email, and what do you want your spam filter to like put a little flag? It's either spam, not spam, correct? So it goes through or not. All right. So then an email maybe. Now, what is it about the email that makes it spam, not spam? The text inside of it, right? Which could be, a link, as you said, or text. Okay, so we're getting into this arena here. So we've got text. Okay, so we'll need to define that, represent this information as the features. Remember, F1, F2, ... FM. Do you see that? All right, good. So N, what about N? How many do you have? Do you think? Let's take the university, right? And you've been hired as a contractor, and your job is to build them a spam filter, and they say you can have whatever you want. You cannot take it out, but you can work from here. So what's N?
Maybe 100,000 emails.
Do you think you can get 100,000 emails?
Oh, yeah.
All right. So then why 100,000 if you can get more?
Oh, yeah. You know, the point. You even win.
Yeah, I mean, so here, this is another thing, right? So in machine learning, why is it that Facebook, Google, and all of them are so successful at machine learning? What is the combination that gives them all the success? Massive amount of data, right? And then they just unleash deep learning algorithms and let them learn. They don't even know how they learn, right? They just learn, right? That's the idea, because remember, it's getting correlations, right, between the text and the class. Got it? So what number do you want to do then? What's N?
2 million?
2 million. Okay, that sounds like a good number. Get a GPU and you can do it. All right, so 2 million works perfectly. All right, so we're good. Now, let's think about this one before we talk about the features, right? How do you get the annotated data? Since this is a classification problem, that means that for every email, which is a sample, you need to know if it's spam, not spam. How do you get that? Yeah, go ahead.
Add a button so every time a student opens their email, then they have to click on whether that email was spam or not.
Nice. I like that solution. I really do, actually.
For a whole semester.
For a year. That's a good one. That's actually what Facebook and Google do, right? Every time you like, every time you comment on a picture, every time you do something, give it a thumbs up. You're basically working for Facebook and Google and for free, right? So so yeah, you're annotating, but I like his solution. So Jason's solution is actually pretty good, because it makes sense to actually build that application, because let's say that you decide to go another route and you're just going to read every email and annotate. It's going to take you forever and you'll produce maybe 10,000. Whereas if you build this application over a semester or a year and just let's ask students, like explain this really well to students, make it in their best interest somehow to do it, give some incentive.
They'll never get spam again.
Yeah, so whatever motivates them, right, to do it, you will produce a lot of data, and actually very good data, right? Good data in general, because when a human looks at data, then it can be reliable. Got it? So very good solution. I like it. Now, is the data set balanced? What I mean is, what's the balance between samples that are not spam versus samples that are spam? What do you think? You have to guess. How much spam do you think you get in a day, or the average person gets in a day? 5%. There we go. Okay, so then you can basically expect something like that. So it's a 95 to 5% balance. So is this a balanced data set or an imbalanced data set? Imbalance, right? And once again, you have now here, because you have 2 million, it may be okay. It may be okay that the model actually can learn to distinguish between the two. Otherwise, the same techniques could apply. You can keep the 5% and then, out of the 95%, just keep like 10 to 15% to make it a little bit more balanced. But you basically build a model that it's going to give you a lot of work, like false positives, right? And so that means that it's going to give you a lot of things that it thinks are spam and they're actually not. Okay, so you can do that. Got it? All right, good. So now I think we just have one thing left, right? Which is the features. So what are the features here? How many? What is M? What's that number? And then, how do you get it?
If we go on the Jason solutions, it's yes or no, yeah. The student says this email spam.
Right, but that's the label, right? That's the Y. I'm talking about the X. So yeah, so you're a student. Well, actually, let's think about it. You're a student, right? And you're gonna mark this is spam, not spam. How do you know that it is spam or not spam as a human?
The language they use, there's no the bottom of all text, if there's bad grammar.
Okay, what else?
The
The links. Now I can send links. I do this all the time. Like, here's the link to this and the link to that. So is it just links or something in the link? The text in the email. Okay, Jason. Yeah.
IP address, it's like not part of the network.
Okay, so IP addresses to go outside the network, things like that. Win $1 million. What was it that you guys found? Was it was a keyword that you found that was like free, right? Free this. Yeah, free. So certain keywords basically is what you're saying. All right. So okay. So again, how do you what is the feature? What are the features? The words, okay. How many words? Which words? All of them. So what is M then? Give me a number. See, this is why this is important. What is the size of M? Each vector. What's the size of it? How do you do it? So you guys want to use words, right? Tokens, let's call them. So that could be also HTTP, could be a word, if you will, right? Or emojis or things like that could be tokens, right? So then maybe we're going to say that we're going to somehow separate all the words by space but also we're gonna look for specific URL related things and emojis. Right? Anything else that we should be looking for?
I was gonna say maybe how many times the word free pops up.
Well, before we do that, actually, this is where I'm going. I'm gonna give you a suggestion. So what if, since students are collecting this, you just, after 2 months, you grab all the emails, right? All the, everything, what, you know, whether it's spam or not spam, and you just run it through an algorithm that just gives you all the words, right? Which would be the tokens, free, you know, win, whatever, but also HTTP, HTTPS, also emojis, and something else that you might think, right? So let's call all of that tokens. So it's gonna run through all that data and create a vocabulary of all the words. Do you guys see that? And then that, some of you were saying the words, right? So then do you use all of them? Could be a million of those. Do you want to use all of them? Or do you use a technique to just, let's say that you're just going to select 100,000, right? Because you want the system to be fast. So which 100,000 of that million do you select? Yes.
Or like, let's say like 15% of the top and 15%.
And how do you determine who goes on the top and who goes on the bottom?
The amount of times it's used.
And that's called a frequency, right? And this is exactly how NLP does a lot of things. It creates these vocabularies of the most frequent terms that appear in the data. Does that make sense, guys? All right, so then you're gonna run through a month's worth of data, right? Create this vocabulary, and then that gives you about 1 million. Then you do the frequencies, you count how many times you see it, and then rank it, and then select the 100,000 top ones. Does that make sense? I mean, it's an approach. I'm not saying it's the only approach in the world. There are others, right? So that being said, then what is M? $100,000, right? Because that's what you decided. Yeah, that's the whole point. So we're just using like reason. So 100,000. Now, what's the value? So let's say this is, you know, F2 over here is like HTTP. And then F1, because it's a very frequent one, is free, right? Yeah, and then FM could be like the emoji like this. I don't know, something like that, right? So what are the values? So this sample, the row, what are the values there, basically? Zeros or ones, right? So it's basically not every sample will have the word free. Do you guys see what I'm saying? Like this one doesn't have it. This one has it. This one has it. The next one doesn't have it. Do you guys understand? So if you notice, I intentionally did it like that because 0 correlates to 0. 1 correlates to 1. 1 correlates to 1. 0 correlates to 1. So what does that mean? With relation to the feature 1, which is the word free. Free is what? Is a good indicator of spam. Do you see that? Now, this is a thing that the machine learning algorithm could give you. And we'll talk about this when we talk about feature ranking and those kinds of things. Does that make sense, guys? Any questions on this word problem? No questions? All right, great. Yeah, so that's spam detection, and you know, these are the kinds of things that we can do. And there's other solutions, obviously, of representing this data. No questions? All right, so I think that's good enough as far as word problems, okay? I'll post this one, look at the ones that I did with the other class, and then, like I said, I'll create a homework assignment that's, you know, 3 to 5 word problems for you to look at. Okay, so now we're gonna basically conclude this. So let me, right.